Hi students, I am B. Ashok, Assistant Professor, Department of BAS1, Kerala University. In this video, we are going to discuss about linear data structures, that is stack using arrays, under Computational Thinking for Structure Design course. The aim of the session is to familiarize the students with the basic concept of stack and its operations using arrays. Instructional objectives. In this session is mainly designed to define the stack data structure and to learn operations of stack data structure using arrays and understand the applications of stack data structure. The learning outcomes of this session are: the student is able to understand and apply the operations of stack data structure and implement the applications of stack. This is the outline of the session: stack data structure, examples of stack, operations on stack and applications of stack. So we are going to learn one by one. Coming to stack data structure, stack is a linear data structure which is going to store the elements in a contiguous manner. Here it follows the principle of LIFO, nothing but last in first out or first in last out pattern. And here the insertion and deletion operations are done at only one end and what we call it as the top of the stack. So in this figure we can see that here it's an array representation where the elements are inserted into the stack like 4, 5, 6 at only one end, and the end what we are calling here as the top of the stack. Here all the operations like insertion and deletion are done at only one end and it is a one side open container. So let us see some of the general examples of this stack data structure. So a stack of books on a table and token stack in banking, as well as stack of trays and plates. These are some of the general examples we are seeing in a day-to-day life. Coming to the stack example, we can see in this figure here the stack is a one side open container where we are performing push operation and pop operation at only one end, and here we are pushing the data into the stack and whatever the data we want to delete from the stack is going to be popped out. We are performing different operations on the stack data structures, basically push, pop, display. So now let us see the operations that we are performing on the stack. See here, this stack is a open one side open container. So in this container we are going to push the data, okay, and this push operation is done based on the stack pointer what we are calling as the top, and once the data is pushed and if there is no limit to insert into that stack, okay, the stack will be in full state or the stack is in overflow, and the operation like popping the data from the stack is called as a pop, nothing but we are deleting the data from the stack. So now we are going to learn how these push and pop operations are going to be implemented by using arrays. Let us see the algorithms for these two operations. These are operations on stack which demonstrate the sample example. So in this first, initially the stack is empty here, and next we are pushing element 8 onto the stack. Element 8 is pushed and it is going to be inserted at the 0th index, and next we are pushing element 14. So whenever we are pushing a new element onto the stack, the top is incremented. So initially in the first case the top is pointing -1 and here it is going to point to 0. So once when we want to push a new element onto the stack, the top is to be incremented. Now it will become 1. At the index 1 the element 14 is to be inserted. Fine. And now when I want to insert 12, now what I am doing here is I am incrementing my top becomes 2. So at the index 2 we are going to push the element 12. Let us go for the next operation. Here it is a pop. So whenever the element is popped, the element which is at the top end is to be removed from the stack and the remaining elements are represented in the stack itself, and the top is going to decremented and it points to the topmost element on the stack. Now the top will become 1. Let us go for the next operation, that is again pop 14. So when we are popping 14, the top will be element at the top is going to be popped out, and here we are going to decrement our top and top is going to point to 0th index. Now Let us go for the next operation, push 6. When we want to push 6 here, so the top is to be incremented from 0 and 1. So here the top is going to point 1, and where we are pushing 6 onto the top of the stack. So if we call on pop 6 and pop 8, so finally the stack will become empty. Fine. So these are the operations that we are performing on the stack. So let us see the push algorithm. So for this push algorithm, we are passing the parameters like for the insertion function, we are passing the parameters like a, which indicates the array, top, nothing but the top pointer of the stack, item, the element whatever we want to insert onto the stack, and max indicates the size of the stack. If top is pointing to the max, then we are printing that the stack is overflow, and we will come out of that. Otherwise the top is to be incremented, that is top is assigned with the top plus 1, and then at a of top we are going to assign that item, nothing but element whatever we want to insert, that is to be assigned at a of top. So this is a algorithm for insertion. You can see in this example, stack before, initially the stack is having the elements like a, b and c, and now we are pushing d. So here the stack size may be 5. In this example, let us assume the stack size is 5. So here the top is pointing at second index. Here let us take the indices 1 2 0 1 2. So here it is pointing at the second index. So here the top is not 4, so it is equals to 2, which means that there is some space in the stack, so we can push this d element onto the stack. So this is a stack after pushing the d element onto the stack, and here the top is incremented, then only the element will be inserted at that specific top position. Now the top is pointing at the index 3. So let us go for the next operation, pop operation. So popping is nothing but deletion. The element is to be deleted from the stack. So usually all the operations like insertion and deletion are taking place at only one end, that is top. So here for this deletion function we are passing the parameters like a, top, item. So here a indicates a array name, top is nothing but the top index where the top is pointing, and item whatever the element we want to delete from the stack. Now if top is pointing to 0, if the top is pointing to 0, then it can be stated like stack is underflow, or else we can rewrite the same statement if top is pointing to -1. So initially top is initialized with -1, so we can correct like this. If top is pointing to -1, then the stack is underflow. Otherwise what we have to do is the element which is at the top index is to be assigned with the item. Go to the statement 3. Here the element at the a of top is assigned to item, and now the top should be decremented. One thing we have to understand, initially top is assigned with -1, which means that the stack is underflow or the stack is empty. So in this situation the element cannot be popped out. Fine. And if the condition is false, that is if top points to any other index other than -1, then we are supposed to display that element, or we are supposed to copy that element from that array, from the top index to the item, and now we have to decrement the top position. So this is a algorithm for deletion of the element from the stack. Let us see the display operation. This is also one of the important operations on the stack where we want to display all the elements. You see here for the display function we are passing the parameters like top, I, a of I. Here top is the top index, the top pointer of the stack, I is the control variable, and a of I is nothing but the element what we are going to have in the stack representation by means of an array. Now you see here, if top is 0, then print stack is empty. So we can manage this condition rather than taking top equals to 0. It is good practice if you are writing top value as -1. So always if top is -1, then the stack is empty. So if the top is pointing to -1, there are no elements to delete. So that's why what we are going to do here is we are going to print a statement stack is empty. There are no elements to display from the stack. Other than that, if this condition is false, if stack is pointing any other index other than -1, so what we have to do is we have to run a loop by using a control variable I till 0th index. So from I pointing from top to 0th index, what we are doing here is we are going to print the elements by accessing them through the array of I, that is A of I. So this is how we are going to display the elements by using stack. Let us see the CRUD operations. These CRUD operations are nothing but whatever the operations we are performing on the stacks, like creation, retrieving, updating and deletion operations. All these are the basic operations we are performing on the stack, are the CRUD operations. So see here, C indicates a create. So this create is nothing but we are going to define an array by which we are going to represent it as a stack. And next one is read. So this function is nothing but accessing or displaying the element. Simply we are calling it as a select function. And next one is update. So coming to the update, so here we are going to update the elements in the stack either by performing push operation or pop operation. And lastly, delete. So once the usage of stack is done, we can remove the entire stack. That is what the delete function. These are the basic operations. Already what push operation, pop, display we have learned, all this comes under this CRUD operations only, but here it is step by step. So let us learn more about these CRUD operations. To implement a stack data structure using arrays in C language, we are going to perform these CRUD operations. Basically, in CRUD operations, create indicates allocation of memory for the stack array with a fixed size, and initializing the top index to -1, indicating that the stack is empty. So this is a base condition that the top is assigned with -1, which indicating that the stack is empty. And next operation is read operation. So reading is nothing but retrieving or accessing the data from the stack. So if the stack is empty, so by means of verifying the condition as the top is indexing -1, we cannot access the elements as the stack is empty. If the stack is not empty, we are going to access and retrieve the elements at the top index of the stack. All the transactions in the stack data structure are possible only through the top pointer or top index. And the next operations are update operations. So under update operation, we can perform either push and pop. Nothing but we are going to manipulate the data in the stack by means of pushing and popping. So whenever we want to push the element onto the stack, firstly we have to increment the top index as well. Next we are going to assign the new element to the stack array at the top index. Already we have seen this operation by means of algorithm. And next one is pop an element from the stack. So if the stack is empty, it is not possible to remove the element. So other than that, if the stack is not empty, so we are going to retrieve the element at the top index and we are decrementing the top index. And lastly, delete operation. Once all operations in the stack has completed, we can deallot the memory for the stack array whenever it is no longer required. Let us see some of the applications of stack. So stacks can be used in handling recursion in functions. So basically whenever we are applying recursion in C programming, so whenever a function is called, the process is going to be stored, the local variables and its addresses are being stored in the stack, that are pushed into the stack, and once a function calling is completed, the pop operation is going to be performed in such a way that the function is called to the returning function, the calling function or the called function. Expression evaluation. So whenever we are having expressions like infix, postfix or prefix expressions, these kind of expressions can be evaluated by using stack by performing this push and pop operations. Compiler syntax parsing. So basically in computer programming, we are going to write the statements with a number of brackets like parentheses, square brackets or curly braces. These are going to be balanced in such a way that to execute the statement in a perfect manner. So in that case, the compiler syntax parsing is also can be done by using this stack only. And next one is undo and redo operations. By performing the thing what we are doing previous and it is already done or it is going to be do, so both the operations undo and redo can also be done by using this stack. backtracking and depth first search algorithms in most of the gamings, as well as in construction of spanning trees, basically in data structures course, where we are going to use this stack data structure for creating those. And browser history, even in browser history also, whatever the previously browsed page, and we can store it by means of pushing it onto the stack, and we can also remove it by using the pop operation of the stack. Memory management, so in most of the computer systems, so the memory is going to be managed by means of stack, where the data is going to be pushed into the memory as well as removed from the memory by means of this stack data structure only. So these are the some of the applications of stack. Apart from this, there are a number of applications are available. So let us see the summary part of this session. So in this session we have discussed about the stack data structure, where stack is a last in first out data structure which stores the elements in a linear fashion. Coming to the operations on stack, we are performing push, pop, display, peek and is empty. So the purpose of push operation is to add the element onto the stack, pop is to remove the element, display is to display the elements or accessing the elements in the stack, peek is to access the topmost element of the stack, and is empty, we are going to check for the stack whether it is empty or not. And the applications of stacks are like function call management, nothing but recursive function calls, expression evaluation, compiler parsing, backtracking or depth first search algorithms. Apart from this, additionally we can also use these stack data structures for undo and redo operations, browser history and memory management. This is the end of the session. Thank you.